Welcome to the React Show, brought to you from occupied Chumash territory by me, your host Thomas, and a delicious bean burrito. So what makes developing software within a business environment so difficult and frustrating a lot of the times? Did you even know it was difficult and frustrating? Maybe you haven't done it before and you're just learning how to program and you think you might want to get a programming job. Well, I think me and many people who have done it for a lot of years can certainly attest to a lot of the frustrations around trying to create high quality software or software that focuses on creating a good user experience, that kind of thing. And how frustrating and difficult that can be within a business setting. And so I just wanted to have a little chat about, why I think that is and, potentially some things that we could, do on a personal level that might make it easier and less frustrating, and even maybe create better software. But regardless, I feel like it's a good thing to talk about. Thank you so much for joining us. I'm currently riding up Fraser Mountain on a fully loaded bicycle. So we'll see how that goes. I really wanted to get a ride in and also wanted to, record something. Well, this in particular, I had this on my mind. So yeah, I have no idea how well this is gonna work, but we're gonna try it and I will pretend like I am not out of breath all the time. So yeah. So what I really wanted to talk about was basically kind of like what it's like to work in the software industry, both for beginners, like, maybe you're learning React or some other programming language and you want to get into it and you're like, hey, what's it actually like? And for those of us that have been in it for a while, all right, that was a bit of a tricky section there. Road is pretty torn up here. Anyways, so yeah, what is it like, for us that have been there for a while? Maybe we can commiserate a little bit, have a shared experience. So yeah, I want to start with a story that's not software. So I sometimes watch this YouTube channel called Linus Tech Tips, and they made their own backpack. And they've talked a lot about the experience. They spent years working on it, and they're very proud of it. They shipped it. Then they found a defect a pretty minor defect in the zipper pulls. If you pulled them like in a way you wouldn't normally do, they might break. So then they, all right, had to catch my breath a little bit there. So it's hard to talk and write at the same time. Anyways, so I don't know if they've even fully shipped it yet, but it seems like they've spent maybe a year now trying to design new zipper pulls that don't have this defect and figuring out a way to distribute them to everyone that already bought the backpacks and this, whole thing, right? And so yeah, it's time consuming and expensive for them to correct any issues. And while a backpack is complex, you can have much simpler products, right? It has nowhere near the complexity of basically any software product. Even if you build the most simple thing ever, it's built on layer upon layer of really complex software, right? Whether it's the operating system, libraries you use. So software is a lot more complex than this backpack. But if we found a minor defect in, our virtual zipper pull, it wouldn't be probably that big of a deal to come up with a fix and redistribute it, right? Especially if you're talking like web stuff, it's like, your boss might come to you and say, hey, we found a bug. And you're like, oh yeah, all right, yeah, it might take me a few days to come up with a fix, and we can deploy it live. And you might have this thing fixed and taken care of in, I don't know, days, minutes even, depending on the bug, right? It's totally different than basically any physical product. But the reason why I want to talk about this is because I think that most people in the software industry, even engineers and programmers, included, but especially people that aren't engineers, they don't understand how widely different these scenarios are and the implications of that. And so I think one of the biggest things I've experienced in the software industry is just this big misunderstanding. Like, people's brains seem to have a really hard time understanding the difference between these things. Like, I don't know, our brains are just like set up to think like, yeah, I make a product, I ship it, it's done. And like, this is a thing you will hear, like, maybe not directly, because people kind of know it's not how it works, but really when it comes to management, investors, owners, people that don't have extensive software experience, this is how it seems to them. You say, I shipped a feature. To them, it's shipped, it's done. It's this backpack, we only go through it's probably not gonna be anything wrong. Most of the products that Linus Tech Tips has shipped, they haven't, come out and said, hey, we found the issue, we're gonna go through this whole process, They might find minor improvements for later versions, but for the most part, you built this thing, you shipped it. It's kind of done. And you have some support to do, maybe there's manufacturing defects and customer service to take care of. But like, for the most part, it's mostly done. And my experience, whether you're selling, enterprise software, doing sales-based, software, or, whether you're in the business of exploiting users via gathering data and manipulating them with ad tech, whatever kind of software, your company is into, my experience is the people sort of at the top rarely understand that software is not this physical product that we've shipped and it's basically done. It's just not... They just don't understand this. And I think even us software engineers have a hard time understanding this and the implications of it. So what are the implications of this? So a software product, it's really easy to update, right? For the most, like, relative to a physical product. Even back in the day when I used to get my software on a floppy disk or a CD, like, that was a lot more work, but it was still easier than, a physical product. Like, you could kind of remake major parts of it and just ship it out. Like, you couldn't remake major parts of this backpack and ship it out. You'd have to ship out a new backpack, and, you couldn't just ship out you could ship out a patch, I guess, but like, not very many people have the skills or ability or desire to patch the backpack themselves, right? So in software, we've always had this luxury of you can patch it so much easier than a regular physical product. And I think this has really created its own curse. It's like this blessing, but it's also this curse. Because what happens is, and I'm sure if you've worked in the industry at all at this point, you'll know exactly what I'm talking about. What happens is, somebody comes to you and says, hey, we got this bug. You're like, yeah, all right, we'll push out a fix. a couple days later, oh, it's fixed. Well, the people, especially higher up, that don't understand this, they're thinking, great, it's done, it's fixed. That's the end of the story. Whereas you, as the engineer, are like, oh yeah, I just, did this quick fix. My boss wanted this as soon as possible. We had angry customers. This is really not like a solid architectural fix, just what my boss needed. I got it in, I got it done. I closed the ticket, right? I got this bug off my back. People aren't hounding me anymore. But we know that's not the end of the story. Really, we're looking at the code and we're like, wow, this code sucks. This bug exists and there's probably 100 other bugs like it because the code quality is terrible. We need to, spend a lot more time improving it. And me adding this quick fix to solve this bug is only making it much worse. Like the price we are gonna have to pay later on for this quick fix that went out quickly is high. And what will happen is the people, higher up the chain, they're not gonna see this. They're just gonna think, like, oh yeah, it's fixed. We're good. We're moving on. It's on to the next feature. It's on to the next whatever idea they have. They don't understand that you're creating, your backpack out of sand, so to speak. Like, you're not creating a good foundation, right? So, of course, what inevitably happens, I don't think I've ever worked anywhere where this didn't happen to a large extent, is the overall quality of the software just deteriorates over time. Adding new features takes longer. There are more bugs. It becomes less fun to work in the code base. And the people higher up don't understand. They're like, I don't understand. You used to be able to add features like this overnight. Now you're telling me it's going to take 3 weeks? And then it actually took you 6 weeks and we found all these bugs. Like, I don't understand what's wrong with you guys. This is the frustration I think a lot of us, that have been in the industry, we've experienced that, like over and over again, that frustration of like, all right. And so what this seems to do is, especially for people that don't understand, they're like, oh, I'm being too easy on them or something, like, or I'm not, doing things right. Like, they think it's a problem with the way they're getting people to do their work or whatever. And so you'll see the tendency for these people is to come back and start micromanaging things. All right, let's have daily stand-ups. Let's have daily updates. We need to keep this thing moving forward. We need to talk about these roadblocks, these blockers. We need to have somebody assigned to everything. We need to really buckle down and actually keep making progress. When the underlying problem is almost certainly nothing to do with the team itself. Like, that's just not the way that this works. The underlying problem is pretty simple. It's the quality of our software is just really deteriorated and we need to invest in, a massive amount in making it better. And this is again where I think it helps to make comparisons to what I think our brains are doing, which is comparing it to like physical products. So we have, a backpack, or at Linus Tech Tips, they made a screwdriver, right? We've got these physical products. We ship them, and then maybe we come up with ideas for improvements, or, let's make a stubby version of the screwdriver, right? We're not really like taking a screwdriver that was 3D printed and we added some, structural shims to it to make it stronger. We're not like building on that screwdriver. No, every screwdriver we're manufacturing anew every time. And maybe you build on the designs and that's useful, but maybe you don't, and it doesn't really matter that much. So yeah, you have a completely different situation when it comes to software, because we aren't working in that way. We're not building software in that fashion. We are essentially taking, like the way it normally works, we're essentially taking a 3D printed screwdriver, and sort of over time trying to improve it and make it stronger and stuff. But like, we're starting with a 3D printed screwdriver. We didn't start with something that was designed to be strong and built out of strong materials, That's just not the way software works. We start with like our initial version. Then your boss or investor or whoever comes to you and they're like, hey, we want this other new feature. We want to make it do this. And so you add that in, you add that in, you add that in. And very rarely does if ever, I don't know if I've ever really actually genuinely heard this, along with a budget to do it, having a boss or somebody come in and say, hey, I know you built this, whole product out of a 3D printed, the worst material in existence. Let's redesign it and actually make it better now that we understand the problem space better. Like sometimes people will say that, but they rarely back it up with the budget to actually make it happen. And I think this creates a whole bunch of other issues. I think this is a big part of why engineers tend to over-engineer, because we're sitting here thinking like, well, they're never going to give me time to actually do this right, so I'm going to try to do it right from the beginning before we understand even how to do it right. Had to take a quick break there. Sorry about that. Not that you would have noticed so much unless I didn't say anything, but found some really awesome Calochortus flowers I wasn't expecting. I believe they're Palmeri. Okay, as I almost fall off my bike here. I thought this road would be paved, but I would say the pavement has seen much, much better days. All right, so yeah, absolutely beautiful. If you're watching on YouTube, I'll try to put up a picture. Anyways, the point I was trying to make about software is that and I want to dive into this more, but there's a gross misunderstanding, especially from the people that aren't directly working on the software, but I think even from the people that are. And I really want to dig into this and talk about it more. One of the biggest things is the complexity. So I talked about this with my dad a lot, he used to be a product designer for a car company or a supplier, automotive supplier, whatever you want to call them. They made car shifters, and he was always complaining about how the software people just always were like, oh, we got a new update, and he had to redo all the, issue a new revision and do all this extra overhead because the software people always found bugs, always had updates. And it seemed like the software part was always slowing things down. And I did a lot of research into this, and it seems to me that software is honestly just way, way, way more complex. I think orders of magnitude more complex than anything we've built as humans, at least that I know of. Anything that, at least compared to what people are thinking of when they're imagining how software products actually work, and they're imagining that screwdriver or that backpack, software is so many more times complex. And like, again, even if your software isn't, unless you're like literally writing this on bare metal, and even then, the firmware underneath that's running on that quote bare metal is probably way more complex than any physical product or most physical products, right? So, and when I looked into this, it was like, and by complexity, I guess I mean like the amount of paths that the code can take, the amount of options is just bonkers. Like it's absolutely wild. Oh wow, look, running water. I have not seen that yet in my trip up from Bakersfield. I'm up in the mountains like above LA here, and man, oh, what I would have given for some water. Anyways, another story, but that's cool. I'll ride along a nice running stream, that's cool. So, sorry, I keep getting distracted. Let's get back to software. So, software, like when I looked into it, is just the complexity, the cyclomatic complexity, all the forms of complexity is just absolutely wild. And so anytime it's like, there's a comparison made, whether intentional or unintentional, with a physical product, it's really a lot more harmful than I think people realize. Like sure, on one level maybe it's useful, but like overall it's absolutely a really harmful thing because it trains our brains to think that it's software is somehow like it when it's just not. We call them both products, you know, physical products and software products. But the reality is software is extraordinarily complex. So to summarize, before I like drone on without bringing this back together, software is both extremely complex, way more complex than a normal physical product, but at the same time, we can also update it way more easily. And so it really, I think, means that software is it's just not as similar to other engineering fields as other engineering fields are to each other. And I'm saying this not as an expert in other engineering fields, so if you are and I'm completely wrong, let me know. And like, I know other engineering fields are extremely complex, like you know, for civil and mechanical engineering, like it's not discrete, you know? Your materials, they don't behave discretely, you know? Your piece of metal, depending on a million different factors, from the purity of different parts going into it to the manufacturing to like, there's so many variables that your, you know, just piece of metal can have wildly different characteristics. And so that is complexity, but it's something that we generally understand. Like, hey, if it's, you know, if all the parts leading up to this, all the ingredients leading up to this piece of metal fall within these constraints, which we can measure, then we know it's going to be, you know, within this range of strength and have this range of properties, right? So I'm not saying it's not complex, but it's more manageable, that complexity, more understandable. And frankly, something we've understood for a lot longer. We've had a lot more time to work with it. But I think it goes deeper than that. I think, in my experience, software is just incredibly complex. And I think we do ourselves a disservice by not recognizing that. But again, going back to the main point, you know, especially the investors, the people that are running a company, even if they're engineers, and I've seen engineers, you know, found companies and later sort of forget this, or maybe they have a boss, or, you know, the users are the boss, you know. Even in that case, maybe you're an engineer and you're running this company, you still have users making demands upon you who don't realize this, and maybe they're the ones that pay the bills. And so in the end, there's just this gross misunderstanding of how software works, how software is, and it creates these like really perverse incentives in the industry. I'm gonna try to keep riding up the hill here because these bugs by the stream are getting to me. But hey, such is life out in beautiful nature, right? So yeah, I think if you haven't been in the industry before, what I would say to expect is that you're not going to have people understanding your software, and especially the people making decisions. So what you will find, I can pretty much guarantee this, is there will be unreasonable expectations. Whether that's in how much you can do, whether that's in the overall quality, that kind of thing. So what you'll end up doing is you'll have some sort of ticketing system, right? Jira or Trello boards. There's a million different ones, right? And the way that you'll end up demonstrating how much work you get done is essentially getting tickets done. And this is because the people sort of at a higher level, to them, they just see this as like, that's how you make progress when you're creating a product. That's just the way it works to them. And so it creates these incentives where, you know, if you want to seem like you're doing well and getting a lot done, you get a lot of tickets done. And you get them through code review, whatever, you know, minimal amount of code quality it takes to get through code review. You get more tickets done. And the people higher up are going to be like, oh, I like this guy. He gets stuff done. But what they don't understand is that they're getting stuff done by sacrificing future maintainability and future quality. You know, so you're going to end up at this point where the quality is going to be terrible, and you'll have other people on the team who might have a harder time, you know, developing with that approach. And so they will end up spending a lot of their time trying to clean things up, write higher quality code, not get as many tickets done. And even if you have an engineering manager that is actually looking at your code and understanding that this is what you're doing, it's a hard sell for that engineering manager. And I can tell you, I've been in that position, you know, as an engineering manager. And you know, it's hard, even though I really wanted to, it was hard even for me to sit there and try to actually understand what the other engineers on the team were doing. You know, like, hey, this person's getting a lot of tickets done. What is their code quality like? And it's easy to go and look at code and find little nitpicks, right? Like, oh, this is good code quality because, you know, they didn't repeat themselves. They, you know, properly followed our style guide, whatever, right? But true code quality, in my opinion, is good design, good architecture. And that is much, much, much harder to tell just in a code review and even for an engineering manager. So, you know, I would do my best in that position to actually understand, hey, is this person actually writing good code? Like, is this actually good design? Try to ignore the little stuff, right? But then even if I did, and this is the point I'm trying to make here, is like, even if I did look at them like, oh wow, they're doing a great job. They really laid a great foundation. This is going to be super maintainable. Selling that to the people higher up, the investors, my boss, the executive team, was basically impossible. Like, I'd come to them and be like, yeah, so-and-so's doing great. They did all this, a really high quality code. And they'll be like, oh, they spend a month on that one feature? So-and-so, I bet they could have had it done in like one day. And you're like, yes, they could have. I could have. Any of us could have. That's not the point. But because of, you know, the way that software is, and because they don't understand how software works, to them, it's just seen as a negative. And like, even you might have a CTO that used to be in engineering and understands this, right? Like, okay, we need to invest in code quality. We need to do this, et cetera, et cetera. And this will come up in meetings all the time, in my experience with higher level management. Like, oh yeah, let's make sure we have really high quality code, blah, 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 right? I can tell you the incentives are just not there. So while a lot of people will say this, and while some people understand it, the end result, the end people making the decisions that have the money, that have the power in the relationship, either don't know or they're focused on short-term gains, and so they don't care. Because who cares if our software is completely useless in a year if, we meet our quarterly targets, right? Or if we raise this round of money, or if you work in enterprise, if we make this one giant sale that we've been trying to chase for a year. Those are the incentives that you're working under. And so even in the best case scenario where your boss understands how to create great software, understands and takes the time to notice whether somebody is actually doing that, and they have the ability to communicate this to people higher up the chain, the incentives aren't there to create high quality software. And don't get me wrong, it's still better to have all of those things, right? Like if you can come in and be like, yeah, our code is not great, but it's better than it would have been if we didn't invest in this a little bit. So I'm not saying this doesn't happen. It's very rare even to invest in it a little bit, but hey, it's better than nothing, right? But the fundamental issue that I see is just the incentives are they're just not there for writing this kind of software. Your incentives, just in my experience in every field I've been, even in internal software, where these pressures might be slightly different. Well, I'll talk about internal software real quick. You might be thinking, oh, internal software will be great. I'll work on a team that is just making software for the company. And so you might think, okay, they'll actually understand that it's worthwhile to invest in this stuff. And, they're not investors who don't understand software. They're not, outside users. Like this is a core part of our company, right? They'll understand. My experience is, companies view that kind of software as an expense. It doesn't make the company money usually, or it's usually indirect enough that, the people higher up are just like, oh, we want to minimize the amount we spend on this. And so they'll cut every corner they can possibly cut. And you'll end up in the same position. I don't think it's really any different, to be honest. It can have different dynamics and like in software in general, your experience can vary massively. I think that's another thing that, might not be said enough is software can be applied to basically anything. So you might join a company that, develops a non-software product and just has software involved. Like my dad's company, building these shifters. Software was involved, but they're selling shifters. They're not, maybe this is changing, but at the time they didn't view it as selling software. And so even in those companies, I guess what I'm saying is in those companies, it might be a completely different culture than say that VC funded startup in San Francisco or whatever. So your working environment can vary tremendously. Like I've been in places where, they're super strict, 40 hours a week, 8 to 5, write down your hours. I've been in places that don't track it at all. I've, been in places that every Friday the company has a happy hour. I've been in, places where it's all about like, okay, we do our time and then we go home and hang out with our families. Or like, there's just a massive, massive variety of situations you can find yourself in when it comes to software. So the actual working environment can vary wildly. It's basically, when I was trying to come up with like what I was gonna, talk about for this episode, that's actually kind of where I started, was like, oh, maybe I can like tell people what it's like to work at a software company. And, I think that's what I am doing, because what we're really talking about is really what is gonna dominate a lot of your existence at a software company. But the truth is, the actual working environment and conditions can just vary absolutely phenomenally because it's such a varied industry. And this is probably true in other industries too. I don't know for sure. I've done a little bit in other industries, but overall it can vary a lot. But getting back to the main point of all this, the constants are that in every case I have come across and I could think of, the incentives and the understanding of what software is are not aligned with what creates great software. So if you actually genuinely care about creating good software, you're not just in this to make money, I can tell you it's always going to be a battle. There's just no way around it. The incentives are not set up for creating great software. And even if they were, people don't understand what it takes to create good software. In my opinion, in my experience, great software that is highly maintainable, it lasts for a long time, has a low amount of bugs, and in the long term is, relatively cheap, is extremely expensive in the middle term. So with software, the initial version can be super quick, super cheap. But then you built this, house of cards, and you have to invest in design and making it better. And that's really, 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 really expensive. People don't understand how expensive it is. It's incredibly, incredibly expensive. And so if you do it right though, and in a few cases, working on my own projects, I've been able to experience this. If you do that right, the long-term cost of your software will be less because you won't have to rewrite everything every 5 years when the thing crumbles down on itself. You can just keep working on it, keep making it better. But what you see in software usually is exactly this issue. So by now, I don't know, if you've been in software for very long at all, what you'll quickly realize is that things come and go in popularity very quickly. And I think a big part of this is things get less popular, partially when they start imploding on themselves. Features don't get added near as quickly to projects that are sort of in this middle term section because there needs to be an investment in the quality, and whether that happens or not, most situations it's not going to happen, but even if it does, it's going to slow down development for a while. And so what you end up with is that investment usually not occurring. Projects can't add features very quickly. They get buggy. People don't want to work on them anymore. You'll end up with just people working on it that have no passion for it, don't care about the quality. They're just there for a paycheck, which is fine. That's what you're there for. I understand that's the way this world works. I'm not criticizing anyone that does that. But I'm just saying that's not the same as somebody who starts this passion project and really cares about the craft, and they're just trying to create something really great from a software perspective for the long term. And so these projects start out really fast, and then there's sort of this long drop off until they just die. And then the hot new thing comes out with new marketing, and it's basically the same thing as the old version, but I don't know, they've made some improvements, but it's more or less the same thing, but a new code base, and it's all clean and shiny, and they're adding features quickly, and then they go down that path as well. And so, yeah, the pattern, that's just the pattern, the way software works. We've become accustomed to it. You don't bother trying to even create this long-term software. Companies just come and go as their software comes and goes, or they migrate from a consumer product to one where it's easier to milk their customers or extract money in some other way, but they're still dying, So the end of what I'm trying to say again here is the incentives that exist are just not there to create long-term high-quality software. Even though I think if you actually understood how to do it and you invested in it, you could create, and I think to some extent we have seen projects like this. They're generally run by people that are passionate. I think this is hard to, I don't want to say, okay, as an example, we could look at Linux. Linux is something that I would say the overall code quality is higher quite a lot higher than the average project at a business. But I think this is one of those cases where the incentives are more in line with creating high quality software, because it's more of a passion project and less of getting the business, influences. And that's where, what I said from the beginning, I wanted to talk about working in software from a business perspective. When you get out of that sphere of, basically short-term gains, investors, whatever, VCs, that kind of thing, you start to get into places where the people actually working on it, interacting the project, do understand and care about this and can invest in it. So that's why you'll see a lot of open source software that outlives commercial software. It's a really interesting dynamic, because on the one hand, usually open source software, it'll die because the people working on it don't have enough money to keep working on it and they need to earn a living. Not because it's like imploded on itself. Whereas in a business setting, the software dies because it implodes on itself. It's making money, but the money isn't going to improving the software. It's going to line somebody's pockets, right? And so we have kind of two different worlds where software dies, but they die for different reasons. All right, so I've basically ranted a lot about how software's, so special and so different, and, the incentives aren't there and all this stuff. But I think there actually is stuff we could do with that. So I do want to talk about that. Like, what can you do as a software engineer to make things better for yourself and for the entire team or company? So what are those things? I think it starts with two things. One, you need to actually understand what makes good software, what is good design, what is good architecture. And that comes with training and experience, but maybe not as much as you might think. I bet, even within a year of programming, you'll have a better understanding of that than most of the people actually making the decisions. So I don't think it takes, a ton. The more you can know and the more you can understand, the easier, it will be when you're trying to communicate things. But you can certainly get started pretty easily and pretty quickly. So we have an understanding, let's say we have an understanding of what makes good software, right? The other part of it is I would recommend, when you're at a company, understanding the incentives. So the incentives generally comes from where is the money made, and, the people that are directly involved in that, what do they understand about software? Because that is going to have the largest impact on how your software is able to be created. Because those incentives are going to come all the way down the chain. Now, in a really big company with many layers of management, this can get distorted a lot, but I think it's still a useful place to start, So taking a look at, like for example, let's say we're a small startup and we're building a consumer product. It's a SaaS service, right? A web service. Maybe we're not directly making much money as a company yet. Maybe the founders are just trying to grow the company. And so they're going to find some metrics that seem like they're growing the biggest. And those are the metrics they're going to, present to investors. Investors are going to be looking for that. And so understand what that is, because once you do that, you'll understand where the pressures are going to lie. And then that ties into communication. So if we can communicate the consequences of the way software is developed effectively, I think it's the best way to actually create good software. So if that's your goal, if your goal is to create really good software, or even just make your life a little bit more manageable, where it's not, let me get tickets done as quickly as I possibly can, that type of thing. I think what it comes down to is identifying those incentives, where the money comes from, and being able to frame consequences in terms of that. So let's go back to our original, scenario at the beginning where your boss comes to you and says, hey, there's this bug, I've assigned you a ticket for it. Please, fix this as soon as possible. It's super important. Take care of this right away. This is, whatever they say, right? This is usually how it goes. So what you can do then is go, okay, so we're in this, say we're still in this, web-based startup, and our metric, let's just pick one, is number of active users or something. And you get this bug report and you're looking into it and you're like, okay, I found a way I can fix this quickly. But it's a quick fix. The real problem is somebody didn't understand this library that we're using and did this part wrong. And so really we need to rewrite a bunch of stuff, and there's probably going to be other bugs like this one, right? And so what you need to do then is come back to your boss, whoever assigned it, the ticket, however it works, and try to communicate not just like, hey, I can fix this in X amount of time, but say, all right, here are some options. And this is the way I like to present it. It's not even like coming in and saying, yes, I will take care of this by tomorrow. It's coming in and being like, okay, so here's option A. I can have this fixed and deployed in 2 days. But if I do that, the next time you come to me with a bug in this area of the code, and maybe you'll detail what the area is, you'll tell them it might take me 2 weeks. And if you come to me with a feature request, it's going to take an extra 2 weeks for us to implement it, because this fix is a hack. It will get it done quickly, but we're going to have to rewrite a bunch of stuff if we want to do this. And so in the future, if you come to me with a feature request, our velocity of user growth might suffer, because it's going to take us twice as long to add any new feature as it would if we just corrected the problem now. Basically, I don't think that was like the best explanation. This is something I'd usually do a few iterations of and write it out and try to think it through. But your goal is to basically communicate that we could invest a small amount of time now to do this right, or pay a lot more later on. And it's not linear. It's not like it costs 2 days to do it right now and 2 days to do it right later. No, it's 2 days to do it right now or 2 weeks later, because the code's going to be worse and it's going to be even harder because we added this hack, right? So then you can have option B. Option B is, all right, to do this correctly, it's going to take 2 weeks. But after those 2 weeks, if you come to us with, a feature request in this area, it's going to take a lot less time. And what I can tell you when you frame it this way is that usually they're going to go with option A. They're going to say, all right, yeah, okay, we just need this fixed. But I understand what you're saying, that, this is going to make things take longer later on. And this is really important, because then later on, when they come to you with that feature, that bug request, you can point to this and be like, hey, I already let you know this is going to take longer because of this. And it won't be a surprise to them. They'll be like, oh yeah, you're right. Maybe I forgot, but you're right. I'll know to expect that this is going to take longer. And so by using this approach, you might not always get everything right away, but you're at least helping people understand the consequences of what they're asking. So in the future, when, things happen, it's not going to be such a surprise to them. They're going to be like, oh yeah, okay, you're right, you told us. It's not going to be, what usually happens is you tell them, oh, this is gonna take a lot longer, and they're not gonna understand why. Or if they do, they're gonna be like, why didn't you tell me earlier? Like, if I had known this was gonna take forever, I would have like come out and done something about it, Anyway, so I guess short version is nobody in that position where they're actually involved with these incentives usually wants to, spend an hour learning how all this works, and, except for, maybe the 3 people that actually listen to this part of the podcast. But the point is, as an engineer, if you want, it can make your life potentially easier. It can also create conflict, so it depends on the situation. But, something you can do is work on effectively communicating the consequences of the actions and the decisions that are made while you're developing the software. And I think that's probably, one of the biggest, I guess, pieces of advice I could give someone if they care about software quality. If you just sit there and try to make good software, the incentives aren't aligned with that, and you're just going to be frustrated. But if you can figure out a way to communicate and frame it in a way that the people making the decisions will at least understand, what you'll do is end up starting to educate and train them in how software is actually developed. So in the long run, it can prove extremely useful because they'll start getting used to this. They'll start being like, oh, okay, yeah, I get it. There's a quick version, has these consequences, there's a long version. And they'll start to see, if they ever choose to let you do the long version, or maybe they'll come back. I've had this actually happen where they're like, hey, we have a slight break. You have 2 weeks to do all these things you've been saying need to be done. Let's just work on them. And then maybe they see the fruits of that labor, where next time they come to you and they're like, hey, we want this feature. And you're like, yeah, no problem. I can do it. Option A, there is no option B, in 1 week. And they're like, wow, this is great. Like, once you start to train and educate people on how this works, it can really pay off. Of course, we've all been there. We've all worked in these environments. Well, not all of us. For the people that have, we all know that it can also be frustrating in its own way. People come and go, especially companies really focused on the short term. They might have, management coming and going, in which case, I don't know what to tell you. Those are bigger problems. But yeah, if you're interested, I would recommend trying out this approach. And I think it's something that takes some practice and some experience, but it can really pay off. And if you're new to software, I guess the thing to be aware of is, if you really actually care about software quality, just be aware that the incentives aren't set up for that, as we talked about, and to just be prepared, because I think that's half the battle too. When I went in, I thought, oh man, I'm going to be working with a lot of people that really care about software and, really want to make good products and really care about the user and all of this stuff. And I was very naive, and that just created a lot of heartache for me, because I'm like, I want to make this really good. I really care. I want to make it good for the user. I want to make it good for the other programmers on the team. This is really important to me. But that didn't align with the way things were run, and I didn't know how to communicate that. I didn't understand this whole dynamic, and so I was just always really frustrated. It was really hard. And over time, I guess what I've learned is that that's just the way things are, and the best we can do is, try to work within that. A big part of it, in terms of like when you're looking for a place to work, will be especially your direct manager. If you can find a direct manager that actually not only cares about code quality, but takes the time to understand if you're writing high quality code and can effectively sort of communicate that higher up the chain, that can be a really great place to work potentially. There could be other issues, of course, but when it comes to actual code quality, that's kind of a requirement. Like many managers, many engineering managers are former engineers. They, in my experience, don't do a good job of this either. Because again, incentives, I won't go into their incentives all right here, but you could probably figure it out. But they're coming at it, and if they have enough time to actually look through a code review, for basic stuff, you're kind of lucky in my experience, let alone somebody that's actually looking to understand how high quality it is in terms of design and architecture and understanding these types of things. And this really ties into, in my opinion, the way we structure software teams is just completely broken. What you really need is somebody whose role is to understand that stuff, and basically an architect. Every team needs an architect. Almost no teams do. So yeah, you're really fighting this on so many levels. But if you can find a place where, the person you'd be reporting to actually understands this and cares about it and can communicate effectively, it can really pay off. But, even if you don't find that, you can still work within what is there, as long as you take the time to understand it. Understand the incentives for the company, the incentives on your boss, and then understand how to communicate and frame things within those incentives. You can create a great working environment in a place where there might not be one to start with, or at least create something that works for you. But yeah, so I'm curious, especially from other people that have, been in software, what they think about this, if they have any other tips or, experiences. And yeah, I hope this was interesting. I hope my, heavy breathing didn't come through too much. I've been pretending really hard that I'm not breathing really hard. But the truth is, I don't know, it's a lot of hard work. Anyways, who cares, right? That's not what we're here for. We're here for rants about software and React, right? Yeah, so I hope you have a good one, and enjoy the rest of your day. Thanks so much for joining us, and I will say, if you've made it this far, you're welcome to show your support for the show. You find out different ways on the website, and actually I've put up a Discord server too recently, so I'm trying to get with the times. Honestly, I haven't really used Discord, so I probably did it all wrong, but it seems to be what all the cool kids were using, have been using. Everyone's probably onto something else now. But I was an IRC person, and things die hard. But yeah, so I'm going to try that out. So if you have React questions or questions about this episode or working in the software industry, definitely you're welcome to come and hang out. And I can't promise I'll be on all the time, because like right now I'm up in the mountains and I don't have signal, I don't have internet. But when I'm available, I'll hop on, and hopefully other people that are knowledgeable can share their opinions too. So yeah, if you want the link to that, I think I set it up right. You can find it on the website, thereactshow.com. Anyways, now that I got all that out of the way, I hope you have a fantastic rest of your day. Thank you so much. Take care. Goodbye.